hi guys. I'm sorry I haven't recorded in a long time. Just remember, we're gonna be learning about neutrinos. Yay, okay. I'm wearing my lab coat, which is new actually, from the Natural History Museum. And don't mind her. Don't mind this little one. She'll just make a little bit. But she's actually being a little bit behaved, so good job, Andromeda. Okay, so first we're gonna go this, this, and then this. Okay, so first, what are they? They're fundamental particles. Can you say that?
Fundamental particles.
Yay, okay, good. Now, so this is what we're going to be looking at right here. Okay, so right, this is an atom and this is a neutrino. A neutrino cannot be divided into more pieces. But an atom can be break up and form new things or smaller things. It can break up and turn into like electrons, which are so neutrinos are also very cool to electrons. See, here's an electron, and there's so the only thing that's different is that they don't have a charge and they have zero mass. Okay, next question. Da-da-da-da. Where do they come from? That is a good question, Mom. You actually asked that. Where do they come from? They can come from you when potassium is breaking down. Like here's some potassium breaking down, right? It can also come from black holes, I think. I'm not sure. It can come from inside of the sun, nuclear reactions. It can even come from inside the Earth, and reactions in the Earth's magnetic field causes showers of them. Right? Because of reactions. So it causes showers of these little buddies. I call them buddies. Okay, next one. How can you catch them? This is actually a really good one. So this is one of the detectors us humans built. So it's called the ice cube, and it explains stuff. It catches neutrinos, right? This is a neutrino going, right? And then once it collides with a foe or with an atom, it puts pure inside of it. It puts something that's pure. It's like pure, I don't know, it's called like pure something, but it's pure something. And then once it collides with the atoms in that it explodes and it releases all of its information and energy that it had, right? And then it releases it to the detector. And then the detector sends it to scientists all around the world. Right? Right? So it detects it to scientists all around the world.
I have a question.
Yeah?
Why do they call it the ice cube, or why do you think they call it the ice cube?
I think, first of all, because it's like a cube. It's like a cube. But also, the ice, what they mean by ice cube, isn't what you think they mean.
Where is it? And what do they mean?
Here, look, let me show you. So what they mean by, don't mind that. It's just a little bit noisy. What they mean by ice cube is that it's in the icy place. It's in Antarctica, and it's like a cube here. It's like a cube. Like it's kind of like a cube, right? But it also is in the ice, like inside of the actual ice. It's like a cube, really. Like it's like what it detects is a cube. Like the detectors are in the cube shape.
And why do they put it in the ice? What makes that a good environment to catch neutrinos?
I think it's because it's pure. Like completely pure.
I see.
That's what I think. I'm not sure.
I have another question. I see something written at the top in green. It says ghost particles. Can you explain what that means?
Yeah. So, they're like ghost particles. So what they mean by ghost is actually really, really cool. What they mean by ghost? What they mean by that is that they're kind of like ghost. They're kind of like ghost, right? First of all, ghosts, like, they can go through you, right? And they're also particles. So they're like ghosts because they can go through, like, a building for a house, for example, right? Like ghosts, like, you know, ghost stuff. They can go through a lot of things, except for each other, right?
Do they go through us?
Neutrinos, yes. I mean, ghosts can go through us, right?
Neutrinos.
Neutrinos can also go through us. Right? So they're kind of a little bit like ghosts. That's why it's ghost particles. That's what I mean. Okay?
Awesome. Thank you.
Bye.
Bye. Thank you.